So word problems are really just real world things. On the STAR test, STAR test writers are going to go straight from the first part of this question straight to part D. But I know you need to be able to answer A, B, and C before you're able to answer part D. So I'm going to give you each one. They're not going to ask you this later on, but you need to ask yourselves these questions. So here we read together. It says the function y equals 25x plus 500. Oh, look, an equation. That seems important. Represents your monthly rent y. Well, there's one of our variables. Monthly rent when you pay x days late. So we now know what our variables are representing. We're going to write that down in words. Our independent variable is always our x variable, but what does x represent in real life for this problem? The days that we pay our rent late. That's what x represents for us today. Our dependent variable is always our y. X is the days late. So what is my output? What is my dependent variable? The rent. The cost of my rent. We also have to know the difference between discrete or continuous to be able to know what type of domain and range I have to write, since there's two types. Okay? The question I asked myself to figure out if it's discrete or continuous is to look at my input. With my input, that's what's important right here. Can I pay half a day late and it be different than if I paid a whole day late? So if my rent is due on a Monday and I don't pay until Tuesday, can I pay a different price if I pay in the morning versus the evening? No, it's a whole day late, right? Which means I can't have any half days, meaning this is discrete data. Because there are no such things as paying a half day late on your rent. You either pay a whole day late, pay on time, or you pay 2 days late. Okay, we can't pay it a half day. So we get to the actual question here. Now remember, A, B, and C is not something that the STAR test writers would put in there for you. They're questions you have to ask yourself. The main question here says, if the max number of days late you can pay is 5, what is the domain and range for this data? Well, I saw domain and range, so I automatically write down Dr. XY because it's going to help me remember which one's which. When I'm dealing with the domain, which is my x's, I need to know the different days late I can pay. What's the smallest number of days late I can pay? 0. And since this is discrete, all I have to do is list these days out. What's the next day I can pay? And then 2, and then 3, and then 4, and then 5, and then 6. Is that right? No. Oh, why not? Oh yeah, it told me the maximum days I can pay late is 5. After 5 days, yikes. Now, a couple days ago, we took notes and we had an example of this where we've had the domain and we created the range. Does anyone remember what we did to create that range? We took the domain and we plugged it in. We're going to plug in our domain to that equation we were given in the question itself to figure out the outputs or this monthly rent cost. If I pay on time, which means I pay no days late, I'm substituting what number into this equation? 25 times 0 is 0 plus 500? So the first number in my range is 500. If I pay 1 day late, 1 times 25 is 25 plus 500. So I pay 1 day late. I have $525 that I owe my landlord. Wow. What happened if I pay 2 days late? Another $25. How about 3 days late? Another 25. Another 25. And 5 days late? $625 I owe my landlord. There's my domain and my range for this situation. We found the domain from the equation, what they gave us. I find the range by plugging in the domain. Let's see one more example. This one's going to change slightly. Again, when we're doing these, you have to physically put yourself in the situation and saying, this is really happening to me. In this one, we have the function y equals 0.25x plus 20. Ooh, look, an equation. That seems important. Represents the height measured in centimeters that a plant grows over a certain amount of time. This time they didn't actually tell us what x and y stands for. We have to think reasonably here. The independent variable we know is the x's. What's the input when you're growing a plant? Is it time or is it height? That's the input. I'm going to tell my plant 3 centimeters, and the plant's going to just automatically grow. No, it has to grow over time. That's what happens when you plant plants. Okay, so our time, and what is our time measured in? Our time is measured in centimeters? In weeks. In weeks. It says measured in weeks. Yeah, right here. LOL, classic. Time centimeters. I love it. The dependent variable is the y. So obviously this one is the height of the plant. And what are we measuring height in? Centimeters. We have our input. We have our output. Think about this situation. You legit just planted a plant. Can I measure its height? Like at half a day? Yeah. Time is always continuous. So we have continuous data here, which means we're going to no longer, I can't talk and write at the same time. Time is always continuous, which means we are not going to use a discrete list anymore. This is a no-no. We're going to be using the inequalities to talk about our domain and range. That's what happens when we have continuous data. All right, we're only going to let this plant grow for a maximum of 4 months. What is the domain and range of this situation? Well, I saw domain and range, so I write down Dr. XY because I know that helps me. Domain is the input. What's the least amount of time that I could let this plant grow? 0 time. I just planted it, right? Boom, I just planted it. This is domain, so there's an X there. And what did they say is the maximum I could let it grow? 4 what? Oh, but we're measuring in weeks. So how many weeks are in 4 months? There's about 4 weeks in every month. So that means there's about 16 weeks in 4 months. So we know that my end time is 16. Just like the discrete example, when we have a domain and we want the range, what can we do to create it? Plug it in. Plug in the domain. Now, a second ago, we had to plug in 6 numbers. We had to plug in 0, 1, 2, 3, 4, and 5 to make the different outputs. How many numbers do I have in this sentence? I only have 2 numbers as my endpoints. There's like a bajillion in between them, so I'm not going to plug in a bajillion numbers. I'm going to just plug in those 2. I'm going to plug in my extremes, my smallest and my largest, into that equation. If I plug 0 into that equation, 0.25 times 0 is 0. 0 plus 20 is 20. So how tall was my plant when I planted it? 20 centimeters. Cool. And I'm going to let it grow for 16 weeks. If I plug 16 into that equation, will someone check that out for me on their brain or in their calculator? 0.25 times 16 plus 20? 24. I know I just wrote all over myself, but whatever, it's fine. So this plant can grow potentially from the 20 centimeters when I started to up to 24. I know the growth rate of this kind of plant. This is what farmers do to try to decide their crop yield. Now here's the deal. Sometimes I'm going to give you the answer choices in math sentences. Okay, here's my math sentences. And sometimes I'm going to give you the answer choices in English sentences. So this is what they look like. The only thing is it's not more complicated. The numbers in these English sentences are always in the same order that they are in my math sentences. So to fill in the first one, I would say the domain is all real numbers greater than or equal to 0, because that's the same order that they started, and less than or equal to 16. That's the same English sentence as the mathematical sentence that I used in the math version. So for the range is all numbers greater than or equal to, what number should go first? 20, because that's the number that went first in my inequality. And less than or equal to 24. It's literally the same order, so don't ever get confused when the answer choices are in word form as opposed to math form. Go ahead and glue these into your spiral. These are going to be helpful for you on the word problems I've given you on your homework. Also because we hadn't done enough of them yet in our other notes. Don't lose this.